Good afternoon. I'm Mary Kramer, President-elect. I would like to welcome our radio audience, club members, and their guests to the regular Friday meeting of the City Club of Portland. As is our custom, we'll welcome and introduce our new members first. Please hold your applause until each one has been introduced. Lesh and James Hillier for their hard work in bringing these members to us. Today is the day we were to vote on amendments to our Articles of Incorporation and bylaws as printed in the March 30th bulletin. And we're very sorry, but we are having to cancel the science breakfast that was scheduled for April 11th. It featured Peter Spencer, who was talking about In the Mind's Eye, Oregon First, the World Next. Next Thursday, April 12th, the Arts and Culture Standing Committee, chaired by Amy Richter, will hold an open forum, Portland's Changing Skyline, Pioneer Place. Featured speakers are from the Rouse Development Company and ELS Architects. It's at noon, 2 World Trade Center, and I believe the Standing Committee put some information on the table for you if you're more interested in seeing who all will be there. We hope you'll be able to go. The specific location is also printed in your bulletin. Next Friday, April 13th, our regular program will be another of our Fast Forward series. It's Fast Forward to 2000. It looks like to me it's going to bring some science fiction alive as experts on the subject of biotechnology application fill us in on new developments. Our speakers will be Dr. Karen Rodlin, an assistant professor of cell biology and anatomy at Oregon Health Sciences University, who also co-chairs the Oregon Biotechnology Industry Council, Dr. Dennis Berger, chairman of the board of Epitope, Inc., and Dr. Russell Menz, who is director of the Center for Gene Research and Biotechnology at OSU. We'll be back in the Mayfair room at the Benson. On Friday, April 20th, we'll have Politics Back to City Club. We'll hear Bob Koch, incumbent city commissioner, and challenger Gretchen Kafori debate. It will be held in the Benson's Mayfair room too. Remember, if you have a question, fill out the form in the bulletin and mail it to the club no later than April 13th. Today, our board host is Cheryl Warren, member of the Board of Governors and chair of the membership committee. She is the executive director of the Portland YWCA. She'll have the privilege of asking the first question. We will open the meeting to questions from club members after our speakers' prepared remarks. Preference will be given to questions from the mic. We will ask written questions as time allows. Fill out the forms on your table, hold them up after the speech, and our staff will gather them. As I read about our speaker today, Dr. Alice Stewart, I was reminded of Linus Pauling's statement, "Science is the search for truth, not a game in which one tries to beat his opponent to do harm to others." I think that pretty well sums up her life as a medical sleuth, a detective, a private eye of the medical world searching for the origins of cancer. Her quest began back in the 50s when British physicians became concerned about the rise in leukemia among children 2 to 4 years old. Her question, is there a prenatal factor contributing to this fatal disease? After sifting through the data and interviewing mothers, she identified the culprit as prenatal x-rays routinely used to check fetal position in utero. This almost doubled the chance of cancer. That's the famous Oxford Survey of Childhood Cancers. That outcome led her to study the health of Hanford nuclear workers and Hiroshima-Nagasaki A-bomb survivors. More recently, she studied the effects of background radiation. Her questions center on, 1, are current radiation standards adequate? And 2, does background radiation contribute to the spontaneous cancer mortality rate? There was evidence to support this notion from an independent researcher as well as a state of Washington health study. For a time, controversy reigned, and even data was withheld by the U.S. Department of Energy. Then the 3 Mile Island Public Health Fund chose Dr. Stewart's research as a project and awarded her $1.4 million to study the situation. The Secretary of Energy was persuaded to release the precious data. Sifting through it now is a team, including those folks at Portland State University. She's enhanced the funding by adding some other monies from her 1986 prize, the Right Livelihood Award, sometimes called the Alternative Nobel Prize. Currently, she is a senior research fellow at the University of Birmingham in the United Kingdom. She's a fellow of the Royal College of Physicians, an adjunct professor at Portland State University, and director of Childhood Cancer Research Institute in Boston. Dr. Stewart is here to tell us of her experiences as a medical sleuth scientist, searching for the truth. Please join us in welcoming Dr. Stewart.
You've already received such a succinct account of what I've done that I really think I ought just to be standing here ready for those questions on the topics raised. But I'll try and fill out with a few points relative to the projects that, with which I've been associated. The sleuthing all began in 1955. This, for those of you who can remember that date, was a time when the whole medical world was rather worried by the rising death rate from leukemia. You know, we've been accustomed to the idea that lung cancer death rate has increased out of all recognition as a result of smoking, and during the 50s this was it was actually in the early 50s that the association with smoking and lung cancer was found. But when I tell you that the increase in the lung cancer death rate at that time was, I was going to say, almost as nothing compared with the increase in leukemia, you will imagine what the alarm was. We now know that, of course, this was a merely temporary phenomenon. It was almost certainly due to the effect of antibiotics on a form of cancer which, before it becomes clinically recognizable, is eroding your immune system in the same sort of way as AIDS does, and making you therefore liable to die from all sorts of infections before the true state of affairs is declared. And so when antibiotics came along, they, as it were, they revealed the true frequency of leukemia for the first time. But take your mind back to the time when the increase was actually operating and none of this déjà vu knowledge was there. You can see that there was a very considerable anxiety about this. Now, I had been, up to about the second year of the Second World War, just a practicing clinician. I had no formal training either in epidemiology, there wasn't any in those days, and or in radiation. So it's of some interest to know how I came to be involved in the present radiation controversy. But it happened the following way. Because there was this rapid increase in leukemia, and because I was in charge of a small department in Oxford University, it was looking for some funding, I tried to find a point at which we could make an epidemiological entry into this problem. Now, the trouble was that though the leukemia was increasing as fast as it was still a very rare disease. And nobody had yet done any group study of the condition because of this sparsity of cases. No doctor, and in those days, I was going to say, but just before this increase, a general practitioner in England, who with a busy practice, would probably never have seen any case of childhood cancer. That tells you how much things have changed when I now tell you that leukemia is the second commonest cause of death between the ages of 2 and 10. Or I shouldn't say leukemia, all forms of childhood cancer. But that change, you know, is it's partly the revealing of the true situation with leukemia and the other malignant diseases, but it's also, of course, the disappearance of the other causes of death. That is the main thing, that we no longer expect children to die in the way that they used to. Well, then, so here was this disease. Was there any way into the subject? Now, the thing I thought of at that time was it would be a good idea to study children, because they seem to be suffering most from this increase. A very unusual age group of children was suffering most. Children between 2 and 4. Actually, you can see now why it was these children. These are the mirror image children. You know, children between 2 and 4, they've recovered from they've proved themselves strong enough to live. In other words, they've survived infant mortality, and they've not yet gone to school and met with the new dangers of meeting with other people and getting infections. So they're usually regarded as really, at any rate, in a temporary safe period. And that, of course, because they were, that is why they were showing the leukemia most, but that was completely hidden from us at the time. So at any rate, I put forward a scheme to study these childhood leukemias by epidemiological methods. And as I say, my main purpose in doing it, it sounds rather crude, was in fact to get some funding, to get a worthwhile project that would gain some funds, because we were in great difficulty. We had no funds. Unfortunately, it failed in its main objective. But one member of the committee who actually turned down the project, and I'll tell you what it was, came up to me afterwards and said he had £1,000 in a non-recurring sum of money from some other fund. Would it be any good to me? So I said, well, half a loaf is better than no bread, and accepted it. And that was how the Oxford survey started. What was the intention of my survey, and why was it turned down? The intention was to go to the mothers of children who had recently died from the disease, to see if there was anything in their antenatal history particularly, but anything in their pre-illness history, that might form what you could call the collective memory of the mothers, which had somehow escaped the doctors. And in order to do this, there were only 300 children who died of leukemia under the age of 10 in Britain, so that you had to go far and wide for these cases. You would need some controls, so I said we'll have a second group of dead children, children with other malignant diseases, and we'll match each dead child with a live child. Now, I've just told you that in detail because that was the pattern that was set, and for which we didn't get any grant at all. But with my £1,000, I said, right, I can't afford to interview these children. They're scattered all over Britain. I had collected the death certificates for 3 years, so I had 900 leukemia cases and 900 other cancer cases. I knew the address, could go to it. And I went to the local authority public health departments of Britain at a very timely moment, namely just after we'd established the National Health Service, so that we were all agreeing to work under a cooperative basis. And that was how the survey got done. The £1,000 was spent me travelling around, going to each local authority and saying, here are your children who've died. We would like you to go and have an interview with the mother. You are the maternity and child welfare doctors. They will accept you. They won't think anything wrong about this. And you're also in charge of birth registers, so every time you get a successful interview with a mother, pick a typical control from your birth register and do an immediate following interview with a live mother. Here you might meet with refusals, but there are plenty of these cases, so get any one of them, any one child that does it. Now, we hadn't done that. I got marvellous cooperation from medical officers, and we hadn't done it more than 30 times. Think of it, 30 case control pairs came back to Oxford, interviewed, and we could see in that pack of 30 the significant finding, which didn't explain the rise in the leukemia, which I've almost told you what that was, but it was an independent finding, which came from that very simple-minded notion of go and ask the mothers. It was almost too much for the doctors. But they had, what the mothers had shown in those first 30 pairs of cases, is there was, in many respects, you can imagine, it was a questionnaire that asked the mother all about, first of all, she let her talk about the child's illness. We weren't so interested in that. But then she was to go right back to the time when she had the pregnancy, and how did the child get delivered, and what illnesses did it have before the child fell ill. And exactly similar questions were asked of a live child, cutting off the dates at the suitable moments. And the one difference that stood out of this pack was that the one group of children had been x-rayed twice as often as the other. Now, that was a startling finding. We didn't expect it at all. And, of course, hurried arrangements were made to check up on the mothers. Please find out where these mothers were x-rayed and go to the x-ray departments and find the original records and so on. You can see that it started off something. What I didn't know as it started off was it was going to start off the need to go perpetually monitoring childhood cancers by this very simple method of going and interviewing the mothers through our maternity and child welfare centres of Britain. Do it day in, day out as these cases come in. They're not all that common. And gradually collect information on a whole lot of topics. Because what I want to tell you about is that whilst the survey is best known for the fact that it had this prenatal X-ray risk, it has enabled us to become, and by the way, that finding is very uncomfortable and very difficult to reconcile with many attitudes towards the safety of radiation, either from background radiation or from occupational exposures or from late effects of the atomic bomb. It's a finding that has been at constant variance with repeated attempts to say that low doses of radiation, you can go below a certain dose of radiation and not have any effect. It stood out like a sore thumb as being incompatible with that. But we've come now to be quite comfortable with many other feelings about childhood cancers. And as I was introduced to you as somebody whose prime interest is in what we call the etiology of childhood cancers, which is absolutely correct, I like to be thought of as that sort of person, not really trying to puzzle out the causes of childhood cancer, rather than somebody who's a radiation expert, which I'm not. So I was very glad to have that. And the survey has been very largely responsible for gradually acclimatizing ourselves to the following ideas. All children who die of cancer almost certainly are suffering from a disease which was implanted before birth. Almost certainly it is a disease which is implanted, if anything, within 3 months of conception. Now, not every case, but it says most of childhood cancers are probably coming up very early on in development. And, all right, that is the start of this disease. What is going to happen thereafter? Well, it's going to be influenced by the fact that though the disease remains silent, we all know about cancer latency, in fact, something very subtle is happening to the child. So the Oxford survey is gradually familiarizing ourselves with the idea that during cancer latency, something is going on. By inference, it will be going on in adults as well as in children. So the more insights we can get into the cancer latency story, I think you will agree, the better off we will be in understanding the whole process. For instance, I'll give you 2 examples here. During the time that a child is incubating his cancer, and you will notice that is from birth onwards, those children are becoming increasingly sensitive to infections. They're actually, instead of doing what a normal child is doing, becoming increasingly resistant to infections. They've got that sort of growth on their side, but it's being impeded all the time. So they're coming up as children who are going to die more easily from infections than a normal child. And that, of course, is why we weren't seeing the true frequency of leukemia until the drugs come along that help people with immune system defects. Well, that's a very important concept to have. And pari passu with it is another one. We inoculate children against infections. And you know, it's been saved some children from getting cancer. Of course, the children who are saved, nobody's ever known that they were on the way to cancer, so we can't pinpoint this. But our survey has been able to show that the effect of inoculations is to have reduced the frequency of childhood cancers by operating by what we call a cancer inhibitor effect. It's managed to reverse the process, again probably by some action on the part of the immune system. The opposite of that of having the infection, which lowers your resistance, is to give a boost to the thing. Well, I think you will agree that this is very important. And one of the most important things that has turned up is that X-rays taken shortly after conception are far more dangerous than X-rays taken shortly before birth. Now that is telling you that you're becoming decreasingly sensitive to the action of the X-ray. The action of the X-ray is probably the same every time. It's causing so many mutations. But you're responding as a target tissue in a different way if you're a tiny little embryo from if you're a mature child. I'm mentioning this because of some very recent work coming from England, almost going to unite the three branches that I've had into adding one very important ingredient. You've no doubt heard of leukemia clusters. It means, and particularly clusters of childhood leukemia, it means areas or places where you're pretty certain that the number of children who've been dying of cancer in a recent or a particular period of time has been excessive. It's a mini epidemic, or the impression of a mini epidemic. Now, one of the most obvious of the mini epidemics in Britain was occurring in the vicinity of our big nuclear power station, our big reprocessing plant, which is called either Windscale or Sellafield. It changed its name, but it's not succeeded in hiding its bad reputation. And as a result of that becoming a strong area of focus in the context of our survey of Britain, it has been possible to prove that in this particular cluster, that one of the factors, one of the most important factors operating, the only identified one, it doesn't account for all the cases, but it counts for a high proportion of them, is that they were offspring of men who were working in the nuclear power station, who had the highest doses received in the 6 months before the child was conceived. Those children, those extra cases, were almost certainly the effect of damaged sperm. Fresh sperm about to make the child. Now, I think you will agree that this has given a sharp light on etiology of children's diseases that we're going to have to pay very close attention to in the future. We always think of maternal influences with children's diseases, but there is one moment in development when the male element in your constitution is more vulnerable than the female. And this has come about through this long history of studying childhood cancers, bringing in information about X-rays and gradually focusing on that one thing. Now, I know I'm only to talk for 20 minutes and I've no idea how much time's passed, but I just want to make it clear for you, if you wish to ask me questions, that there have been two other ways in which we have been able to contribute to this highly controversial subject of health effects of low doses of radiation. Before I cease with the Oxford survey, I must tell you that we have over the years always received a very generous contribution from America to maintain this data collecting centre in Britain. Without this, I'm sure it would have broken down. It was given to us because you couldn't set up a similar thing in America with anything like the same ease as we were able to do in England. But I would like to thank America for that, and to thank America for another thing, and that was as a result of knowing what I was doing in connection with children, knowing the connection with low-level radiation, I got appointed first of all as a committee member for the Mancuso study in Hanford, later on as a more active consultant to him. The great day came when Dr. Mancuso invited me to come and take a closer look at his data, because he thought we could help him with a problem. And I and my statistician turned up in Hanford, and the three of us worked out that there was a cancer risk for workers that hadn't been recognized before. Unfortunately, that work got cut short, but is probably about to revive again now as a result of Admiral Watkins being more open-minded about who should and who should not be allowed to examine the records of Hanford workers. But it also gave me yet another opportunity, and that is to have a look at the data coming from the A-bomb survivors. If there is a big controversy in science, one group saying there is, and in this case, there is an effect of a very small dose of radiation, and the other side is saying there isn't, somebody must be wrong, and he must eventually be able to work out the reasons why the false impression has been going round and strengthened. And the third contribution we've been able to make to this subject is to get some insights into the survivors from the atomic bomb, who, by the way, included children who were exposed in utero, and following up the clue provided by the difference between the two groups of children. Children in England getting extra cancer from a single X-ray. Children in Japan getting a blast of radiation from the fallout, getting no cancer. That was the nature of that clue, and it has eventually led us to discover that there is an element, there is a feature of the data from the A-bomb survivor studies that has been overlooked. It is a thing we call selection. For various reasons, which is too technical to go on to, the experts on A-bomb survivors have always been left with the impression that there was no late effect of the A-bomb other than radiation. We've been able to show that there was a second effect. It was the effect of having killed so many people in the first days that the population that was available for study was both strongly selected in favor of infection-resistant people, and also dose-related selection, because there was only one bomb in each city. And finally, that the reason why this was never spotted was because it was clashing with a third late effect of the A-bomb survivor, namely marrow damage. Now, I hope I've given you an idea that I'm somebody who would be interested in any questions on the etiology of childhood cancers, any questions on whether it is safe to work in a nuclear power station, and if not, why not? And thirdly, why there has been, for so long, the impression that there was no in utero effect of the A-bomb radiation. Thank you.
Cheryl Warren has the privilege of the first question. Cheryl?
Yes, right. Well, first I'd just like to say it was a fascinating speech, and for the people who are listening on the radio, I think you should know that she stood up here with absolutely not a single note, which is a very admirable. I have several questions. I'm not sure which one I want to ask, actually, but I guess what I'd like to know is, since you mentioned you would invite questions about the safety of working in such places as nuclear power plants, that maybe you'd like to make another comment about that, but also I would like to know your opinion as to whether you feel that the government and the society in general is more responsive in the United Kingdom to safety standards and safety in the workplace, including exposure to possible cancer-causing agents. Is it more responsive in the United Kingdom than it is here in the United States?
Well, the answer to that question is that we have a much stronger trades union movement in Britain than you have in America. And through the trades unions, there is much more pressure on the owners of businesses to attend to the health of their workers. And to that extent, I think it is true to say that both the development of occupational medicine and an understanding of industrial hazards has developed under this pressure. Things always develop best under strong pressure, develop more strongly in Britain than in the United States. That's only my personal opinion. But what I'm quite sure of is that in particular in relation to radiation, we've been no better than America.
Susan Stone, member of a club. I had a question about childhood cancer. Has there been an increase in the per capita number of childhood cancers over the last, say, 40, 50 years? And if there has, can you tell us why you think that is?
Yes. What I was trying to say is there was this rapid increase, and that meant the number of the actual risk of dying from leukemia, having your death ascribed to leukemia, is much higher today than it was, say, in 1918, which is covered by your period. That was a time when it was for a child to get leukemia, say in a big city, where all the doctors would flock round to see the rarity of this case. But what I hoped I had conveyed to you is the impression that this was a false impression of too few cases. It was because these cases were getting so infection sensitive while they were developing the disease silently that in fact they always died of infections, and we didn't know that we had leukemia in our midst. My father was a physician in Sheffield, and he used to say the tragedy with childhood leukemia is that it's always the flower of the flock. It's the one member of that family who never had any illnesses. The answer is if they'd had an illness, he wouldn't have had leukemia, he would have died. Now, if you say, has there been any increase over and above that, once what we call, say, the curve has flattened out as a result of discovering all the cases that were, as it were, not seen because the tide of other troubles was too high. We call it the competing causes of death, was hiding the true frequency of the disease, then has there been much increase recently? No, the rates have wobbled about. You can understand how this effect of the falling tide from competing causes of death has, you first get something apparent in America, the wealthiest part of America, and then it spreads to the lower classes in America, and then it gets to the third world and so on. So there are, over the world today, leukemia is still increasing, but I doubt whether there is as yet any evidence of a genuine increase. And I may just, while I'm here and got a podium, a captive audience, I must tell you that I think there's still one hidden group of leukemias, and I think it will eventually surface among your crib deaths.
Dr. Stewart, my name is Press, Dr. Press, a member of the City Club. I have two questions in relation to the cause of childhood cancers. One relates to radiation, not from x-rays of the pelvis of the mother, but in the early 50s it was quite common to use radium implantation for adenoid and tonsil hypertrophy. Instead of the surgery, they would use radiation from radium. They'd implant that. You're probably familiar with that. And I was wondering whether whether you've done studies or whether you feel that that is a cause of later either leukemia or thyroid cancer or other cancers. That's the first question. The second question comes back to your statement about the effect on the sperm of males working in the nuclear plant there, that you felt that impaired the morphology of the sperm and may have caused, you said cancer, possibly also congenital anomalies. Now, although we don't have much of that, at the present time there's a wide expansion of the use of hot tubs and jacuzzis in which the water is heated to about 102, 103, 104, sometimes as high as 110 degrees. And this thermal trauma to the testes of male, there's some studies that showed it decreases the number, decreases the motility, and has morphological changes. Do you know of any studies, or have you any comment on whether or not unduly long exposure in these hot tubs are liable to cause cancer in persons from the males that are involved in this?
Well, I'll take the two questions. The first question, does giving radiotherapy, as indeed it was done mistakenly to treat enlarged thymuses in children. Does that cause cancer? The answer is certainly yes. That
in
work
addition to
has
the
been
thymuses, I was thinking of hypertrophy, tonsils, and adenoids plus the thymus.
I've no doubt it does. I would suspect that those unfortunate treatments would cause a cancer in a young adult rather than in a child, merely because of the latency and because of the age when the child is likely to have had this. We didn't have any examples of that, but the fashion for treating tonsils with radiotherapy fortunately never spread to England. So we had no examples of that in our survey, which was a survey restricted to deaths from cancer before the age of 16. With regard to the overheating the testicles in hot water, it's always been suspect, but I know of no study about that. But it's just the sort of thing that I think there will be sharply revived interest in as a result of finding that ionizing radiation, evidently fresh sperm, and when you think of it, at one stage in their development there's only a single DNA strand. This must be a moment at which you are very susceptible to damage. Interest in this subject will be revived as a result of this Gardner et al. Study of the Sellafield cluster.
Thank you.
Kathy Oxborough, City Club member. I spent part of my childhood living downwind of the Nevada Atomic Energy Test Site, and I'm wondering if you're aware of any studies or could comment on them, on the effects of radiation for people who lived near that test site.
Yes, I'm very aware that I know about the studies, and I'm very aware of the difficulties that anybody faces in trying to prove what undoubtedly must have happened, and that is that there would be, as a result of fallout from this, extra cancers. Why do I say that so certainly? What I didn't include in my preliminary talk was that the Oxford survey has developed to the point where it's been able to test for the effects of background radiation in Britain. We now have records of over 22,000 children's cancers in different parts of Britain, and independently from our survey, we now have measurements of background radiation for every 10 kilometres square of the country. And that, although the 80% of the background radiation is uniform over Britain, there's a 20% contributing to a difference. So this is somewhat comparable to your downwinders. Has there been any effect of that small 20% difference in different parts of Britain? And the answer is that provided you build in to your analysis all the other factors which are known to be influencing the childhood cancers, influencing the frequency of it. And I mentioned some of them. Previous infections. I've not mentioned some other ones. Are you a second-born child or a first-born child? Is your mother an older mother? Have you had pregnancy illnesses? What social class do you belong? What climate in Britain do you? We were in a position to build in all these factors, and when we did so, we found a significant effect of two sources of fetal irradiation. One, the X-rays, and two, the background radiation. The second was stronger than the first because, for two reasons, there was 100% involvement of the second and only 14% involvement of the first. And secondly, background radiation operates in the first half of pregnancy as well as the second half, and the X-rays only in the second half. So much so that the difference estimate that we gave for the contribution made by background radiation to childhood cancers is no less than 63%. So it looks as though low-level radiation or in utero exposure is the single most important cause of childhood cancer. This radiation may be man-made or it may be natural. It's not going to make any difference which it is. But if you're in a situation of a downwind where there's been excess, you may be quite sure that hard as it will be to pick those up and prove that they're there, they've been there.
Jean DeMaster, City Club member. Recognizing the effects of the X-rays on unborn children, we don't do that anymore. Are we repeating this process with ultrasound now with unborn children?
Yes, the marvelous thing about this survey is because it's gone on monitoring childhood cancers, it's able to take in any new influence. Now, in England, ultrasound didn't get going till about 1975. in the interval since then, it's become universal. Do you notice what's happened? As soon as a thing becomes universal, like background radiation, it becomes almost impossible to study, because everybody's suffering from it. So in the interval, it's going to be very, very important to observe what did happen owing to the increasing frequency of ultrasound in the British population. And though I can't give you any figures, I can assure you that, you see, it's going on a cohort basis. We haven't yet, on the full computer analysis, any children over the age of 5. They'll come in the next 5 years, currently, actually. Well, I can tell you that there's no difference between the ultrasounded and the non-ultrasounded children up to the age of 5, but I can give you no information later, and I must warn you that the whole of the X-ray effect came after 5 years.
Chip Greening, member. Now that we've learned our hot tubs are at risk, I'd like to ask another practical question. I think a lot of us in the room, and certainly some in the radio audience, are wondering, well, I'm not going to move out of the city and get out of the heavy radiation zone. What about some of the practical things we face every year, dental x-rays, mammograms, chest x-rays? Do you have some practical advice for us about those?
I'll even take up your first point. Nobody should ever try moving to less background radiations. It's a sort of not in my backyard philosophy, isn't it? We're on this planet in spite of background radiation, and the minor differences that exist between places are not something that you should tend to try and move from one place to another. What you should be doing is directing your philosophy very strongly to saying we're not going to increase or have unnecessary X-ray exposures. We've increased background radiation by national policies which were utterly deplorable. The open weapons tests been recognized, they've been rendered illegal and so on. And you should make every effort in the world to stop such unfortunate and misguided things. With regard to the medical X-rays, of course, the message I'm saying is never do an unnecessary X-ray.
John White, member. You invited a question about the lack of cancers among the Japanese children following the A-bomb test. I'd like to know more about that and what it means.
When we first produced our finding, there was a moment at which everybody thought it was a jackpot finding and very good, and then people had second thoughts and they thought it can't be true. She must have been misled by what the mother said and one thing and another. And that was the main reason why the survey went on. We thought that the doctors would stop X-raying children purely on the whisper and the doubt, and that the only children, therefore the only data available, would be children who'd already been X-rayed but were not yet dead, who would appear on the scene in the next 10 years. And that is why the Oxford survey went into second gear and became an ongoing retrospective survey. Well, it reached the age when it felt it had taken in, actually it became aware that the doctors weren't stopping the X-rays in Britain as much as they might have done, largely because of the contradictory press that came up about our survey. But still, so we didn't actually have a fixed end date. But after we'd done what we thought was we'd scooped up this next 10 years, we then published a paper to show that the effect was there, was continuing, and we now had enough cases even to have the temerity to give a risk estimate for a given dose. It needed converting effect per film into effect per dose, but allowing some little bit of Bible arithmetic. We gave it as the figure that if you exposed 1 million children to 1 rad of ionizing radiation shortly before birth, how many extra cancer deaths could you expect in the next 10 years? And the answer was 600. And that would effectively double the present frequency. So we were saying that 1 rad of ionizing radiation was a doubling dose. It would double the normal risk of cancer if given to a child shortly before birth. This immediately prompted a reply from the A-bomb survivor study, who produced a paper to show that there had been 1,279 children who had been x-rayed in utero through the bomb, whose doses ranged from high to much lower down to very low, but much wider range, of course, than anything we'd ever had in the x-ray. The one thing you can know about the x-ray is the dose is small. You may not know exactly what it was, but you know it was small and temperate. These were a much wider range of doses, and built into this report was the story that if we were right, this particular population should have experienced 26 extra cancer deaths. I beg your pardon, I think it was 36. And they had, in fact, only experienced 1 cancer death. It was a rather unusual one. There were no cancer deaths under 5 at all. There was a girl suffering from a liver tumor age 7. And so they then went to national statistics and said how many would they have expected if just from the national rate for Japan. And they said 0.75. 0.75. So they said, we have not experienced in this population any extra cancer deaths. Dr. Stewart's theory must be wrong. It gave us another wonderful impetus. We went on for another 10 years after that trying to work out what that difference was. But that was the story at the time. Since then, we've heard the following, that this particular group of 1,279 children are now in their 40s. Our survey, of course, never gets into the older age group. It keeps collecting new young cases always truncated to 16. But this, the A-bomb survivor, has been able to be followed up into its 40s. And you will be interested to hear that in the 40s they are getting extra cancer deaths in that group.
I am Member Gilbert Lamb. I have 2 questions, if I may. You mentioned hot tubs as being maybe hazardous in some respects.
Well, I think it'll be studied. I wouldn't like to say it was hazardous, but I think there'll be interest in that.
We have a daughter-in-law who is a Finnish girl, and we put in a sauna as a result of Scandinavians liking saunas. Do they have the same hazard that hot tubs might?
Well, you see, I don't for a minute think that you will find anything from this, but what I hoped I'd said is that I'm sure there will be keen interest to try and be sure. You see, it's a very different thing to have, you've only got to see pictures, or microscope pictures of what happens to cells with ionizing radiation to realize that the trauma that's happening to the cell it's not comparable to just perhaps even getting temporarily a bit too hot and perhaps one odd cell dying. I myself would be very surprised if there was anything in the jacuzzi, but I can see, and in fact, may I say that I can see this interest is already being expressed in this audience.
I was going to ask a second question, if I may. Does the medical segment of our society, both in USA and Great Britain, accept the dangers of the possible dangers, probable dangers of X-rays to the extent that we are diminishing their use?
Oh, you know what, the biggest change is not to diminish the use of X-rays, but to reduce the dose of the X-rays and to have alternative imaging procedures. I would say that the amount of so-called X-ray examinations probably is more intense today than it's ever been, but I imagine the dose per examination is a fraction of what it used to be.
Edith Zabin, member of the City Club. There is so much discussion now and an acceptance almost that cancer is carried in the genes. Is it possible that some of these children who were X-rayed, who had radiation as fetuses, that was in the genes to begin with, and they and the radiation was not the cause, but that they carried it in the genes by inheritance.
Well, in that case, what you're really saying is that there's a sort of latent group of potential cancers, of which, say, the X-ray now brings it out. So in that sense, the X-ray must be doing something, otherwise we wouldn't have found any difference between our X-rayed and our non-X-rayed children. There's no proof either way of what you're saying, but when people say that there's a cancer in the genes, I don't think they mean that you've actually got a mutation, a germ cell mutation there. They mean that you've got a physique, a personality, something that if you do get cancer, you will be one of the victims rather than one of the people who don't. Let me explain. For every cancer induction there is, right, you'd have to have 1,000 of those to get one case of cancer. The mutation doesn't turn into a cancer every time. It's, the body has extraordinary resistance to it, and it throws off its mutations. You're very unlucky to get this gene perpetuating and coming out as a cancer. But some people let it get through more easily than others. And it's as though you're sensitive to the cancer promotion effects, the thing that will determine whether the frequency of the mutation turning into the cancer. But I think the evidence in favor of it being a somatic mutation, a mutation of a body cell, not a germ cell, cancer being that, is overwhelmingly strong, and it comes not, of course, from my survey, but from animal experiments, from A-bomb survivors, from all sorts of areas. And the genetic component says, right, if, for instance, you were doing an animal experiment and you had a sensitive group of animals, you bred them to be sensitive, and you bred these to be resistant, you then give them the same amount of radiation or any other carcinogen, and you would find that a sensitive group came out with, say, 10% of cancers, and these only came out with 5%. It's as though, put it the other way, that some people are more resistant to cancer than others, would perhaps be the best way to say it.
Pauline Kraft, member of the club. I wonder if you would be good enough to amplify on your notion that perhaps there is a connection with crib death and early radiation. Do you see it as being coming from in utero exposure or with some damage to the sperm?
Well, it goes this way. When the increase in leukemia occurred, which I drew your attention to during that period of rapid increase, as a worldwide event, the type of leukemia that was largely responsible for the increase was a variant known as myeloid leukemia. This is the type of leukemia where the mutation has taken place in the bone marrow. The other type of leukemia, called lymphatic leukemia, the mutation has taken place in a lymph node, and the characteristics are carried on, and you can recognize which type of leukemia anybody has. Now, surprisingly enough, although the increase among children was very great compared with young adults, but it got, of course, great again among old people. It was a phenomenon that affected the very young and the old more than the intervening age groups. The children showed no increase in myeloid leukemia at all. It was all due to the lymphatic leukemia. And then another funny thing is they've showed there was no increase under 1 year of age. So I've always maintained that there's still a missing group of leukemias, which are the myeloid leukemias, which would normally have come in first, because that's the faster growing disease, and would have filled out, there's no reason why the children shouldn't have had myeloid except competing cause of death. I got some evidence for this. In our survey, we eventually got enough children who died under the age of 6 months of age to discover that in this group, the risk of being in this group was twice as great for the children who were born in the first half of the year, January to June birthdays, than the second half of the year. Now, there's no seasonal difference, and you cannot influence the month of birth by a later event. So there must have been some competition there. What was it? If you stop to think of it, though there's no seasonal difference between the first and second half of the year, that's if you're thinking in terms of an event happening at since the birth. But if you thought of the event having a peak instance 3 months later, now you've got a seasonal difference. The first half of the year is moving into the summer, the second half of the year is moving into the winter. So I said, let me go out and see if I can't find a cause of childhood cancers. A cause of childhood death, not cancer, that is commoner in the winter than in the summer, and which has not decreased in frequency since antibiotics were discovered. Well, it didn't take much long to see that cot deaths might belong to this group. And I collected 3 groups of crib deaths, and in each one of them, the proportion of children born in the second half of the year was double or the first half. So I actually wrote a paper to that effect. Could it be that there's a hidden cases of leukemia? It didn't catch on, and I didn't include what I later gave as a probable reason for these children dying at night when sleeping. I didn't think of it then. I thought of it then it was just an immune system. But then I said, as the evidence became clearer and clearer that more and more children are getting their cancers very, very, very early in development. We had a twin study that said 80% of our cases were all predetermined by the second cell division. This is almost making your point, but it isn't. There's still time. There's still a little development time in there. And it said, supposing those myeloid leukemias were developing, most of them at that early stage, they would be coming from the ancestral cell from which we develop both the red and the white. So they would really be carrying a hemoglobin defect with their cancer. And what these children were possibly dying from was failure to convert fetal hemoglobin, the hemoglobin that allows you to breathe through a placenta, into adult hemoglobin, which is the one that allows you to convert from the air through the lungs. And then came a bad hitch because nobody could find any evidence of this extra fetal hemoglobin that I was postulating would be found among the sudden infant deaths. They found it among the myeloid leukemias. Children who died of myeloid leukemia under 2 years of age had fantastically high fetal hemoglobins, but there was this missing element. The week before I left England, a hematologist rang me up from Nottingham to say that he'd managed to overcome a technical difficulty. You can't do this test after death. You've got to do it during life, and he'd managed to keep a large enough group of children under supervision to have cot deaths in it afterwards. And he's able to put his series together and say that every one of his cot deaths had too high a fetal hemoglobin. So I now have some reason to think that someday somebody will go after this clue, because all I am here is a person who is trying to resolve a clearly unresolved problem. Why do we get cancer? What factors are there? Which are they? Will children help us? And one of them, you see how neat it would be. Nobody's ever found the proper cause of the crib death. Nobody's ever explained the myeloid leukemia. Bring them together, say I.
Thank you for a very interesting speech. We are adjourned.